We are doing classes on current electricity. We already did current, then we did potential difference or potential voltage, that is V, and also we have seen what is resistance and resistivity. So those who are watching for the first time, all the 5 classes, the link for those classes are in the description box. So please go through those classes before starting this class. Today we will be learning the relationship between the current, voltage and resistance. So that is our today's topic. So let's start the class. So here you can see 2 vessels are there, and 2 vessels are connected using a tube, and when you see the level difference, there is one vessel is having more water and the other one is having less water. So you know the water will flow from the first vessel to second vessel until they are having same level. So here when you look at the level difference, you could see that the level difference is this much. So anyway, since there is a level difference, the water will flow from one vessel to another vessel. Now let us take a second case. Now I am going to increase the level difference between them. So here, in order to increase the level difference, what I did is I just kept the first vessel at a higher position compared to the second vessel. So the water can flow through the tube which is connected. Now when you look at the level difference, you could see that the level of water the level difference between the first vessel and the second vessel is more compared to that in the first case. Okay, and when you look at the flow of water, you could see that water will be flowing very fast in the second case compared to that in the first case. That is in the case of water, you could see that if the difference in level is more, difference in water level is more, then the rate of flow of water will be more. The water will flow much faster than when the level difference is small. So I told you earlier also, you should consider the flow of current or compare the flow of current with that of the water flow. So here this level difference is actually the potential difference or the voltage which we have learned, because this potential difference or the voltage is responsible for the flow of current that we have learned in the previous classes. And the rate of flow of water, we can consider it to be the current. So from the above example, you found that if level difference is more, then the flow will be more. Similarly, we can show that, or we can find that if voltage or the potential difference is more, the flow of current or the current will be more. So today's topic is the relationship between the voltage and or potential difference and current. So first we will do an experiment, and then we will go to the explanation of the experiment. So you can see the experiment. Since it is an electricity experiment, if you are doing it at home, then you should use rubber slippers. Don't do the experiment barefooted, since we are good conductors of electricity. So it's a very simple experiment that can be done even at your home. So let's start with the experiment. Doing this experiment, we need a cell. The positive of the cell is shown here, and the other side, which is flat, is the negative of the cell. This cell is having a voltage or potential difference of 1.5 volt. We can use different cells. So if you combine 2 cells, you'll get 3 volt. Here there is another cell which is having a voltage of 9 volt. There also positive and negative will be marked on the cell itself. So this is a higher voltage 9 volt cell which can be used for increasing potential difference. Then for the experiment, we need a resistor or a conductor. So I am going to use a pencil for that. The pencil lead is made of a graphite, which is a conductor of electricity. So that graphite will be acting as a resistor or a conductor in this experiment. So we will be connecting the cell to this pencil so that current will flow through that. Now we need a multimeter. Multimeter is used for measuring voltage, that is potential difference, and also for measuring current, which is in ampere. Then it can also be used to find the resistance of the material, and so many other uses are there. Here we will be using it for measuring the potential difference in volt and the current in ampere. And also, if you want, we can measure the resistance using this multimeter. Multimeter got a red terminal and a black terminal. Red terminal is the positive and the black terminal is the negative. Now you can see the connection here. The cell is connected to the graphite or the pencil using connection wires. The positive is connected to, positive of the cell is connected to one end of the pencil lead, and the negative is connected to the other end of the pencil lead. Here I have simply used a paper tape for sticking the connection wire. So you can also do that at home if the other connecting terminals are not there. Even then you can do the experiment using a simple cell, two connection wires and one pencil. So this is the connection, and we can find the potential difference between the cells using the multimeter terminals. This is the positive terminal, red one, and this is the negative terminal of the multimeter. So in order to find the potential difference, you have to keep the positive terminal on one end of the pencil and negative terminal, that is the black terminal, on the other end, and just note down the multimeter reading. So you can see it is around 1.5, 1.49, because we are using a cell of voltage 1.5. So almost 1.5 volt will be across the pencil. So we can note down that voltage as 1.5 volt. Now in order to find the ampere, we have to switch the multimeter to the ampere range, and we have to connect the red terminal on the top slot, that is for measuring the ampere or current. If you want to measure the voltage, you have to connect it to the second socket where V volt is written. You have to put it in the second socket. Now we are measuring the ampere or current, so I have connected it to the first socket. Now in order to measure the current, you just keep the positive terminal. So you can find the reading there, 0.05, 0.04, 0.06, etc. So it is slightly changing only because it is not perfectly done. The hand is shaking, and also the positive terminal here is connected to, so I will show you again. When you are calculating, see the positive terminal of the battery, it is connected to the red portion of the red terminal of the multimeter, and one end of the pencil lead, it is connected to the black terminal of the multimeter, so that we can get the value of current. So this is how we have to measure the current. Positive terminal should be connected to the positive of the battery, and the black color should be connected to the pencil lead. So that is how we find the voltage, the ampere or the current. Now you can see that the current is almost 0.0505 range, 0.5 or 0.4 range. So you have to write down the current also. Now next I am going to increase the voltage of the cell. That is, instead of using one cell, I am going to use two cells. So two cells, when they are connected in series, then when they are connected like this, you can get 1.5 plus 1.5, that is 3 volt can be got. That is, I am increasing the potential difference, or I am increasing the voltage, and I'm just going to measure the current here, because you know that the voltage will be somewhat around 3 volt only, because it is written on the battery, so no other circuits are there, so we will be getting almost 3 volt potential difference. Now what we need to do is to measure the current. So in order to measure the current, as I told, we have to keep the positive of the battery to the positive or red color terminal of the multimeter, and then you have to keep the black terminal to the pencil lead. Now from the reading you could see that the current is now 0.18, almost 0.18 range ampere. That is when we applied a voltage of 1.5, we got 0.0504 range, and when we applied, or when we increased the voltage to 3 volt, I got a current 0.18, which is a greater current. Now let us see what will happen if we are going to increase the voltage further. So here almost 1.8, 1.4. Now I am going to increase the voltage. I am going to use the 9 volt battery here. That is, I am increasing the voltage or potential difference. Now let us see what happens to current in this case. So here the voltage is 9 volt. Here also I have to connect the positive terminal of the multimeter to the positive of the battery. Then the negative terminal or the black terminal should be connected to the one end of the pencil lead, and now take the reading. So you can see that the ampere or the current is of the range of 0.35 or almost equal to 0.4 ampere. So that means when I am increasing the value of voltage from 1.5 to 3 volt and then to 9 volt, we can see that the current is also increasing. That is, initially it was 0.06, then it increased to 0.18 and then to 0.4. So when voltage is increasing, the current is also increasing. Correspondingly, the current is also increasing. Or we can say that voltage is proportional to current. Voltage is proportional to current means however the voltage is increasing, with the same proportion the current will also increase. This is actually the Ohm's law. Okay, now we will learn the theory in detail. Ohm's law. From the experiment we found that when we are increasing the potential difference, correspondingly the current will also increase. Or we can write a relationship between this current and potential difference. Current is directly proportional to potential difference, which means that current is depending upon the potential difference in a directly proportional relation. That is, when voltage or potential difference is increasing, the current will also consequently increase. This relation was experimentally studied by a scientist called Georg Simon Ohm in the year 1826, and that relation or that law is known as Ohm's law. That is the relationship between the current and voltage. Now one important thing is there, when we learn the relationship between the current and voltage, this relationship will be good, or it will hold only if certain conditions are satisfied. One condition to be satisfied is the temperature should remain constant. That is, the temperature of the conductor which we are taking should remain constant. The second condition is that the physical conditions of the conductor which we are taking should be constant. Physical condition means if we are using a conductor having constant length and area, that particular length and area, then that should remain constant throughout the experiment. Then only this Ohm's law will is applicable. Now let us state Ohm's law. So the statement of Ohm's law is, Ohm's law states that the current flowing through a conductor is directly proportional to the potential difference across its ends, provided physical conditions and the temperature of the conductor remains constant. So when you are writing Ohm's law, always it is important to mention this part, that is the temperature and the physical condition should be constant. So if temperature is varying, or if the length or area of the conductor is varying, then Ohm's law will not be correct. It won't hold good. So Ohm's law is applicable only if the temperature is constant and the physical conditions of the conductor remain constant. So that is very important. So we have found the relationship between voltage and current, that is voltage is proportional to current, or I'll write it as current is proportional, because according to the law it is current is directly proportional to the voltage or the potential difference. Now if current is directly proportional to voltage, we can write voltage is also directly proportional to current. That is, when we are increasing voltage, current will also increase. Now in order to remove the proportionality sign, as you know, you must multiply with a constant, that is a constant multiplied with current. Potential difference is equal to, or voltage is equal to, a constant multiplied with current, and this constant is actually the resistance. So we have learned about resistance earlier, so it is easy for you to understand. So the constant here, it is the resistance. So instead of the constant we can write R, resistance multiplied with I. Okay, or you can rewrite to make the equation more simpler, or to tell it easier, it is equal to V is equal to IR. Okay, so this is the equation for Ohm's law, keeping the temperature and physical conditions to be constant. So it is easy to remember, always remember it in this equation format. Okay, even though we can write it as V by I is equal to R, a constant, it is better to learn Ohm's law as V is equal to IR, because all are in a linear way. That is V here you will get confused whether I is in the denominator, V is in the numerator. There will be a confusion. So better always when you are learning Ohm's law, you learn it as V is equal to IR. Once the equation is known, if you want to find the unknown, you can use your mathematical skills to find the value of the unknown. So better learn Ohm's law as V is equal to IR. So you can even use some mnemonics for remembering this equation, like VIR. Okay, VIR, or a very important resistor, you keep in mind. So it will be easy for you to remember if you use some mnemonics for remembering is VIR. So V is equal to IR. So that is the equation for Ohm's law. Now if you put this equation, that is V is proportional to I, or I is proportional to V, into a graphical form, you can see that, suppose I am drawing a graph. You take I along y-axis and voltage along x-axis, and if you are going to plot the graph, you will see that when you are increasing the voltage, the current will also consequently increase. So what you get is a straight line graph. So when voltage is 0, current will be 0. When you increase the voltage, the current will also correspondingly increases. So you get a straight line graph. And if you find the slope of the graph, you know how to find the slope of the graph. Slope of the graph will give you the value of resistance. So if you find the slope of the graph, you can get the value of resistance. So the slope, actually it is the difference between y-axis and difference between the x-axis, that is dy divided by dx. If you find the value, you can easily get the value of resistance from the slope of this current voltage graph. So that is about Ohm's law. Now in order to conclude Ohm's law and in order to keep this law in your mind, I'll show you a simple cartoon here. So here you can see that the voltage here, potential difference and current, they are handshaking. So the voltage is saying, when I grow, you will also grow with me. So he is helping the current. Voltage is helping the current to grow. Then you should know that they need the support of temperature. So only if temperature is remaining constant, this can be attained. So temperature is helping them. I will remain constant without disturbing you. So here the temperature is actually helping them to have this growing relation. Then the resistance, you know that if length and area of a conductor is constant, the resistance will also be constant. So this picture actually show you how resistance, voltage, current and temperature, they are related in Ohm's law. So I think we should also be like potential difference, helping others to grow when we are growing. So that's all for today's topic. Next class we will see about the actual experimental setup of Ohm's law. Today I just saw you how to do Ohm's law at home. So we were not using any voltmeter, ammeter, rheostat and all, and I didn't give any circuit diagram for doing the experiment. Next class I'll do the detailed experimental setup of Ohm's law in a scientific manner, or the way in which it is done in the laboratory, the circuit diagram, and more about Ohm's law will be done in next class.